Hello everyone. So in today's session, we are going to learn about digital sensors. So for that, we have our LDR sensor. So this is an LDR sensor, which is like digital input, or we can call as a digital sensor. And the full form of your LDR is light dependent resistance. So it is depend upon your light intensity. For example, if I bring a torch on top of it, so it will be like it has more light intensity. So we have a resistance value. And if I put it in a shadow or like in a dark area, so it will have a low light intensity. So on the basis of that, it will vary like how much the light intensity is falling on that. And by using this principle, in our LDR, we are going to create a light lamp which will turn on the LEDs when we have dark areas, and it will automatically turn it off when we have light, efficient light available there. So for that, we need some materials. So here we are using like jumper wires. We have male to male as well as male to females which we require. We have breadboard, LDR, we have our Arduino board for controlling. We have some LEDs which we turn on and off, and we have resistance of 220 ohms. So let's start by creating the circuit first. So for that, let's keep all the things aside. Let's take a resistance, some jumper wires, and our LDR sensor. Okay. Let's put our LDR sensor in our breadboard like this so that each of the pins have different pin holes. You can also put it here. So here you can see we have put it in three different holes. Like in my case, the pins are 13, 14, and 15. These are the pins which I have. Here you can see. Now, what I want to do, first thing I want to fetch the values that, as I told you, it is a digital sensor. So it will give us a value that is a 0, either 1. So if there is light, if it is 0, then in dark it will be 1 or vice versa. We will check it by using code. Let's use some jumper wires to connect it with our Arduino. So let's say we have three pins, that is our VCC, ground, and our output. If you see the first one is our VCC, then we have this ground symbol, that is our ground. Then we have D0, means digital output. So let's connect them. So I use this first pin, that is our VCC, to 5 volt. I can directly use it here. Let's say. Then we have the second as our ground. So ground means we have this pin as negative. Then we have our output pin. So for output, I haven't connected till now, so I leave it. After that, let's use two more wires to get the power supply from our Arduino. So we will need a 5 volt. So 5 volt is our positive. Then we need a ground. This is my ground. So this is my basic circuit. Now we have this output. So it is a digital. So I can connect in any pin in our digital which I have. Let me connect it to the 8 number pin. So after that, let's go to our code. So here, let's start by defining the pins in mode. We have the pin at 8, and it will be our input because it is a sensor, so we have to fetch the values from it. Let's fetch the values. So let's use a variable and value, or let's say LDR value equals to digital read. Digital is for digital pin. Read because we are reading the value from it, and inside that we will pass one value, that is pin number, that is 8. I want to show it, so for that we will use serial monitor. So first we have to initiate it, serial dot begin baud rate 9600. Now let's use it here, serial dot print. I want to print this LDR value. with a delay of, let's say, give some room, 200 milliseconds. Now let's run it. So before running, you have to do one more thing, that is connect your circuit with Arduino. So when you connect your circuit, you will see that it has two LEDs that has been turned on. One is for your power. Let me show you. So here, if you see carefully, here one is your VCC pin, and another one is your like output, which is your D0. So when it sends something, the another one LED will turn on, and one for power, which is by default turn on. And if not, there you can see it has been turned off. Now let's upload the code. As the code has been uploaded, now let me show you. So here you can see that our code has been uploaded, and let me resize it also. So here you can see that we got a value that is 000. When I place my hand over it, it is like 1111. So like when light is falling on it, the value is 0, and when it has dark, it is dark, then the value is 1. Because it is a digital sensor, that's why we are getting 0 and 1. Let's do some changes. Let's write ln also after print so that everything will be in a new line. Okay, you can see when I put my hand, it is 1, and when I release it, it is 0. Now, apart from that, we can do one more thing. That is, we can change its value. So, for example, if you see it here, so use a screwdriver, and if you see here, we have this blue color box. We call it as a potentiometer. So, what we can do, if I rotate it, you have to rotate it very slowly. Otherwise, the potentiometer will break it internally. So I can control this intensity like currently, for example, if you see, I have made it in dark, but it is like less sensitive. So I can increase or decrease the sensitivity also by rotating it. Let's rotate it this much. I think it has reduced the sensitivity. I have to rotate it anti-clockwise direction. So here if you see, you can see it is more sensitive now as it was previously. Now let's use these values to turn on and off an LED. So let I'm using this red color LED, which will turn on when we have like we have dark area. Like when we got 1, it will turn on, and when we got 0, it will turn off or it will not lit up. So let's use that. Okay. So let me hide this comport. Okay. Now first let's add this to our breadboard. So it has to pin positive, negative. So what we are going to do in the positive section, we are going to use a resistance, and with the help of this resistance, we are going to give it a positive supply. Just our LED in the positive pin, I can get resistance and give it a positive supply. You can also give it like you can also replace it. Both will work. Like in the negative one, I have given the negative and connected the resistance to it. Okay. And for the positive one, let me use one jumper wire, and that jumper wire will connect it with our digital pin. That's I want to use pin number 7. So I connected it, the positive one with pin number 7. Here you can see. This is my connection only. Now let's write the code for it. So first I have to define the pin that I have used. So I have this serial number, that is output pin. Now here LDR value will return us 1 or 0. So we have to use one conditional operation, that is if condition. If our LDR value is equals to 1, means when we are holding like this, we are giving it shadow. then what should happen? Digital light, that is the LED should turn on. Which LED? In pin number 7, it should be high. And we have another condition, that is else it should be low instead of high. Let's make it low. And to work it accurately, let's register delay from it. Now let's upload the code, and let's see the COM port also. So it is like currently it is 0. So the LED is not turning on when I had it. Here you can see, because it is I will need the sensitivity. That's why it is like working. Here you can see. If I show it here, here you can see. So when there is dark, LED will turn on. Or let me reduce the some light from my area. So if I reduce some light, you can see automatically the light has been turned on. So this is our night lamp. When there is like the value of your light is when we have dark area, the light will automatically lit up. And you can also see from in the console that OCR monitor that 1 and 0 are shifting down. So that's it for today. See you in the next session.